Students, this is question number 6. Let me write the question down. A curve is such that dy over dx is 6 over 3x negative 2 raised to the power of 3, and a of 1 comma negative 3 lies on the curve. A point is moving along the curve, and at A, the y coordinate of the point is increasing at 3 units per second. Now we are asked to find the x coordinate of the point, the rate of increase, right? Find the x coordinate, find the rate of increase of the x coordinate of the point at A. And point B, or question B, is find the equation of the curve. Okay, so what they are asking us in question A, they are asking us to find the rate of increase of the x coordinate at A. So rate means what? D over dt. And what are we to find? The rate of increase for x coordinate. So at A, so this is required. But what are we given? Given is what? The y coordinate of the point is increasing at 3 units. This is given. So d over dt of y is given to be as 3 units. Now this means, what does this means? This means dy over dt is equal to 3 units. Now you consider dy over dt. What is dy over dt? If I want to write dy over dt as some terms involving x, then I can write it like this: dy over dx multiplied with dx over dt. Dx and dx can be cancelled, right? So ultimately, what are we doing? We are just rewriting dy over dt in this fashion. Now what I wish to do is, I would like to have dx over dt and then move this dy over dx to the other end. So if I were to do that, this would be dy over dt. I'm just cross multiplying. You can either cross multiply or you can push this down. So if you push this down, you will be having dy over dx, and on the other end you have dx over dt. This is what is required. Now dy over dt is given as 3 units, and dy over dx. Now dy over dx, we need to go over here and get this value, right? So the point A is what? Represented by this coordinate 1 comma negative 3. Now what I wish to do is, I would like to calculate dy over dx. We know that dy over dx at the point A of 1 comma negative 3 is equal to 6 over 3 times of x is equal to 1 negative 2 raised to the power of 3. Now what is this? This is equal to 6 over 3 negative 2, that's 1 raised to the power of 3, that's 1 cubed is 1. Now this is equal to 6. So what we need to do, take the 6 and place it over here. 3 divided 6 2 times, so this is equal to 1 over 2. Fair enough, right? So what have you got? You got the rate of increase of the x coordinate. So I'm going to complete the question here. So therefore dx over dt is equal to 1 over 2 unit units per second. So that's the final answer, right? So with that, we move on to the next one. So students, we got the next part. We expected to find the equation of the curve. Now we have dy over dx to be equal to 6 over 3x negative 2 raised to the power of 3. Now what I'm going to do is I'm going to be moving dx to the right and bringing 6 to the left. So this is going to be dy over 6 is equal to dx over 3x negative 2 raised to the power of 3. Now we can integrate both sides, right? Integrating both sides. Now this is actually a constant, so you can rewrite it as 1 over 6 times integral dy. Now we need to focus on integrating this quantity. So what I wish to do is I will start up like this. Consider integral dx over 3x negative 2 raised to the power of 3. Now let me take 3x negative 2 to be equal to some u. I differentiate with respect to x. This would give me 3 times dx over du. So that goes to the other end. So this 2 will be 0. So this is going to be du over here. But we got only dx. So dx is equal to 1 over 3 times du. So if I were to rewrite this, in place of dx, I'm going to substitute du with 1 over 3 taken out over 3x negative 2. That's going to be u. So substitute u there. So you got u cubed. Move this up to the numerator. That would give me u raised to the power of negative 3 times du. Integrate this, you get u raised to the power of negative 3 positive 1 divided by negative 3 positive 1 times 1 over 3. This is equal to 1 over 3 times u raised to the power of negative 2 over negative 2, which is 1 over 3 times 2 is 6. You have a negative sign. U raised to the power of negative 2, push it down, you get u squared. So this can be rewritten as 1 over 6 times u squared. But my u is 3x negative 2. So it's going to be 1 over 6 times 3x negative 2. You have a 2 there, so place that. Now, since we are dealing with indefinite integrals, you need to have the arbitrary constant c. Now on the left hand side, probably I will take this as say sum 2. Therefore 2 is rewritten as integral 1 over 6 times dy is equal to integral dx over 3x negative 2 raised to the power of 3. But you have integrated this. So this is equal to negative 1 over 6 times 3x negative 2 raised to the power of 2 positive c. Now if you were to integrate this, you get y over 6. Now to get the value of c, let me rewrite this. Y over 6 is equal to negative 1 over 6 times 3x negative 2 raised to the power of 2 positive c. This is what we've got. Let me check. Okay. Now the main point is that we need to get the value of c. So to get the value of c, so therefore at a of 1 comma negative 3. So we got. So what do we have? So x is equal to 1 and y is equal to negative 3. If I were to take this as say sum 4 or sum 3, therefore 4 is rewritten as negative 3 over 6 is equal to negative 1 over 6 times 3 times x is 1 negative 2 raised to the power of 2 positive c. This is negative 1 over 2 is equal to negative 1 over 6 times 3 negative 2. It's going to be 1. So 1 squared positive c. Push this to the other end. So you get 1 over 6 negative 1 over 2 is equal to c. So therefore c is equal to, if I were to take the LCM as 6, I get 1. 2 divides 6 3 times. So you have a 3 there. So you got negative 1 negative 3 will give you negative 2 divided by 6, which is nothing but negative 1 over 3. So therefore c is equal to negative 1 over 3. This is what you're getting, right? Okay, so now what you need to do, you need to take this value and substitute it over here, right? So therefore 4 can be rewritten as y over 6 is equal to negative 1 over 6 times 3x negative 2 raised to the power of 2. You have negative 1 over 3, so place that. Now we need to get the equation of the curve, and that means we need to get rid of this 6. So multiply by 6 throughout. So what do we get? We have to multiply by 6. So 6 goes all the way. You get y there. 6 is multiplied, so naturally this 6 will get eliminated. So you get negative 1 over 3x negative 2 raised to the power of 2. Now 6 is coming here. So 3 divides 6 2 times. So you have a negative 2 there. Right. So this is the equation of the curve, which is the required equation of the curve. Okay, that is exactly what is required. So that completes the solution for this question. So we move on to the next one.